Good morning, Junior 4. Today we will talk about concept number 3, which is speed. At the first, we will explain how can we measure the speed of something moving fast. To measure the speed, we need to know the distance and time. We need to know distance and time. Distance, what's meant by distance? It is the distance that object travels. It is measured in kilometers or meters. And also we need to know the time. Time, it's the time taken by the object to travel that distance. So again, to know, we need to measure the speed. We measure the speed by two measuring our physical quantities, which are known as distance or time. Distance, it's measured in kilometer or meter. Time, it is the time taken by the object to travel that distance, and it's measured by hours or seconds, and also it can be measured by minutes. We can also we can measure the speed of object in the previous pictures in kilometers per hour or meter per second. So meter, distance, kilometer or meter. Time, hour or second. But speed we measure it by kilometer per hour or meter per second. Those are the measuring units of speed. Now we will talk about cheetah speed. Let's ask some questions. Does the cheetah run faster than the human? What do you think? I think that the answer is no. Does cheetah run faster than a car? Mm, let's see in this lesson. You know that cars, trains, and other vehicles can move very fast. But what about animals? Today we will talk about the cheetah, which one of the cat species, and it's the fastest land animal or fastest wild animal on the earth. Cheetah speed. Cheetah run faster than the human. Cheetah can run 100 meter in 6.4 seconds. So they are fastest land animal. Cheetah is the fastest land animal. It can run 100 meter in only 6.4 seconds. It's very fast. Scientists found that cheetah can go from speed equals 0 to a speed equals 96.5 kilometer per hour in only 3 seconds. That represents 3 strides of the cheetah. A high speed train can go from the speed 0 to speed equal 96.5 kilometer in 37 seconds. But cheetah can go in this speed in only 3 seconds, while fast car can reach the speed in more than 4 seconds. Why cheetah is so fast? Speed is what distinguishes the cheetah from other animals and help it to survive as a predator. Why the cheetah is so fast? Because it has a lot of adaptations in its body. The speed of the cheetah is the result of some special physical characters, like at the first its head. The head of the cheetah is lower than its shoulder. Those are the shoulders of the cheetah, and the head is lower تحتيها كده. The cheetah's head is low to the shoulder, which decrease the air resistance or friction of the air. Also, its nose. Cheetah's nose has large opening. Nose has large openings, which help it breathe a lot of air. Also, the heart of the cheetah. Cheetah has a large, oversized, powerful heart. Cheetah's claws. Cheetah sticks its claw into the ground while running to push off the ground which make it faster. Also, its spine or backbone, it's flexible like the spring, act like a spring for its legs muscles. That's why all of these characters make the cheetah fastest land animal. And also its body, cheetah body is lightweight. It's not heavy, it's not fat, it's lightweight, where the average weight of its male is about 41 to 50, 41 to 45 kilogram. So it has lightweight. Objects move at different speeds. The relation between distance, time, and the speed. We have a lot of objects like here the runner, a man who is running horse, car, a rocket, and all of them they move at the same period of time. All of them move in about 4 minutes. But the distance, what about the distance? At the first, the runner took about 1.5 kilometers in only 4 minutes. The horse took 3 kilometers in 4 minutes. Car move 6 kilometers in 4 minutes. A rocket took about 400 kilometers in 4 minutes. طب let's comparison between them. Let's compare between them. Which one is the faster? All of them they move at the same time. All of them took 4 minutes, but the difference is in the distance. The rocket took long distance, it moves for a long distance in this fixed time. So the rocket is faster. Why? Because it moves a long distance. While the runner is the slowest one in all of this picture because it only took 1.5, it took short distance at the same time, which is 4 minutes. From the previous table, we can conclude that a runner, horse, car, rocket can travel different distance in the same amount of time. All of them took the same amount of time because they have different speed. They have different speed. How do you know which is the fastest one? We will look at the distance, and the one who travel longer distance, it means that he is the fastest one. But we have to fix the time. All of them move at the same amount of time. Now we are going to talk about this activity, which is basics of speed. Um, Basics of speed. Speed is measurement of how fast or slow something is moving. If I wanted to describe if this object is moving fast or slow, I will use the word or the term speed. Speed measures the distance that the object travel over the time. So, to measure the speed at as we said at the first, we have to talk about the distance and also the time. It's distance over time. The speed of an object is not affected by direction. It doesn't matter if I'm moving forward or backward, to the right, to the left. It doesn't matter. It's not affected by direction of the moving object. For example, if a car moves forward 5 meters in 1 second, then it moves backward 5 meters also in 1 second. So it moves forward 5 meters in 1 second and back also 5 meters in 1 second. Does it matter? No, because all of them, both of them, in the two cases, the speed still 5 meters per second. Speed, it is the distance traveled in a certain amount of time. Speed is estimated in unit of the distance over time. To measure the distance, to measure the speed, as I said, we have to know the distance and the time. So we will make the unit of distance over the unit of time, or divided the time. Therefore, we can calculate the speed as the following, dividing distance over time. Speed equal distance over time. So speed, we can say the speed is defined as distance per a unit time. This is the speed. As I said at the first, distance, it's measured in kilometer or meter. Time, it's measured in hour or second. But speed, so the speed equal distance over time. So the measuring units of speed are meter per second or kilometer per hour. So some common measuring units of speed: meter per second or kilometer per hour. To compare the speed of object to the speed of another object, measure the distance of both of them. I have to measure the distance and also measure the time. Measure the distance that both of them travel in the same amount of time. And I fixed the time in the same amount of time. The object travel greater distance, it means that it's fast, but in the same amount of time, moving by great speed. For example, if there are two runners, they are in the race, one of them moves 6 kilometers in 1 hour and the other moves 9 kilometers in 1 hour. Which one is faster? The one who moves 6 kilometers or 9 kilometers? Of course, the 9 kilometers. Both of them move in the same time, which is 1 hour. So the one or the runner who moves or runs 9 kilometers is faster because he moves for a longer distance. So the second runner moving it at a greater speed because he travels a greater distance, which is 9 kilometers in the same amount of time, which is 1 hour. Let's talk about measuring the time. Now I will fix the distance at the same distance, but I will change the time. The object travel the same distance in the smaller amount of time, is moving at greater speed. For example, if two cars are racing 1000 meters, both of them are moving by the same distance. The first car finished the race in smaller time. For example, it finished it in 10 seconds, while the other one, this one finished it in 10 seconds, while the other one finished it in 5 seconds only. So which one is faster? The one who finished the race in 5 seconds or 10? Of course, 5 is better because it took on a shorter time. It took only 5 seconds. So the one who took shorter time or smaller time is moving at a greater speed. Measuring an object motion. How to find here in these pictures, faster moving things have higher speed. This one has higher speed. Slower moving object have lower speed, like the bike and the train. The train is moving by high speed while the bike is moving by lower speed. How to find out the speed? How to measure the speed? This distance between the two places is how far these places are from. Again, distance between two places means how far these places are from each other. They are far from each other. How long it takes to travel a distance depends on how fast are you moving. If you are moving fast, it means that you will reach faster. But if you are walking slowly or moving slowly, it means that you will take longer time and you will uh, you will be slow. If you walk from your house to your school, it will take a longer time to get there than if you travel at the same distance using the bicycle. The one or the boy who is using the bicycle is faster than the boy who is walking. Aeroplanes and the high speed trains can cover a long distance in a short period of time. How to calculate speed? At the first, you have to know the distance. As I said, to measure the speed, I have to know the distance. Distance. Then you have to know the time. So to measure the speed or to calculate the speed, at the first I have to know the distance and also the time. Then what I will make? I will make distance, speed equal distance over time. Speed equal distance over time. Then I calculate the speed. Here you must know the distance traveled through by the object, traveled by the object. Then you need to know the time taken by the object, this object to travel that distance. Then find the speed. How to find the speed? By dividing distance by the time. Speed equal distance over time. Speed equal distance over time or divided by time. Let's take a problem. For example, if your school is 3 kilometers away from your house and it took 1 hour to walk there, calculate your rate of speed. Here, this problem, in this problem it's written that distance equals 3 kilometers and the time equals 1 hour. So how to measure the speed? Speed equal distance over time. So I will make 3, the distance is 3 over time, which is 1, equals 3 kilometers per hour. This is the first problem. Let's take another problem, story problem. If a bus traveled 600 kilometers in 6 hours, calculate the average of the bus speed. Here in this problem, we will change the numbers or the values. Distance equals 600 kilometers. So here the distance is 600 and the time is 6 hours. So speed equal distance over time. I will make 600 equals 600 over 6 equals 100 kilometer per hour. Here we are going to measure the speed. At the first, we will bring some books and a ramp, stopwatch, measuring tape, masking tape. We'll bring also some balls of different masses. Some of them are they have big mass and small mass. At the first, set up the ramp as shown in the figure. Then measure 1 meter from the end of the ramp and place a piece of masking tape on the floor as finish line. This is the end line. Roll the three different balls gently down the ramp without pushing them. Don't push them. One at a time. Start the stopwatch. Start the stopwatch as you release each ball. Then stop the stopwatch when the ball pass to the finished line. To reach the finish line. And now we have three balls. One of them is blue, for example, green or red. The first one, the blue took 20 seconds. The other one, green, took 25. The red took 30 seconds. Observation: the blue one, which took 20 seconds, has biggest mass. It has big mass. Reach the first line in 20 seconds. It has the fastest speed. So we conclude from that when the mass increase, because the first ball it has bigger mass. This ball is the biggest. So it took shorter time. So it means that it's fast. The red ball, which has the smallest mass, this is the red ball. It's the last one. Travel the same distance, but only but it took longer time, 30 seconds. So it means that it's slowest. The green one, it's in the medium mass, so it travel this same distance in 25 seconds. It has medium speed. Conclusion: the speed of each ball depends on the mass of the ball. We conclude also, when the mass increase, it means that speed increase. When the mass decrease, it means that its speed decrease. So the speed of the ball can be changed by changing the height of the ramp also, of the ramp surface, smooth or rough. If I increase number of books, the speed of the balls will be faster. Now we will talk about calculating the speed. For example, the speed of the bike is 6 kilometers per hour. Speed of the car is 80 kilometers per hour. The speed of the train is 300 kilometers per hour. As we said, speed equal distance over time. To calculate the speed, if we have two cars, the first car moves 10 meters in 5 seconds and the other car moves 20 meters in 5 seconds. Which one is faster? To know which one is faster, I have to calculate the speed. I will make speed equal distance over time. The first one moves 10 meters in 5 seconds, so I will make 10 over 5. So its speed equals 2 meters per second. The other car, I will divide 20 meters over 5 seconds to calculate its speed. So its speed will be 4 meters per second. It means that this car is faster than this car because the speed of this car is 4 meters per second, but the first one is 2 meters per second only. As I said, the first car or the yellow car travels 2 meters in 1 second, while the other car, which is dark, moves 4 meters in 1 second. The dark car has greater distance than the yellow or the light car in the same time, which is 1 second. So the dark car moves faster than the lighter one. In the previous, we conclude that two cars moves within the same time, which is 5 seconds. So in this case, we can determine faster car through observing the distance. If they have the same time, we will observe the distance. The one which took longer distance, it means that it's faster, but the one who took shorter distance, it means that it's slower. The same here, Amir rides his bike in 10 kilometers in 1 hour. How fast is he going? I will make the same problem or the same solution. Here the distance equal 10 kilometers and the time equals 1 hour. So I will make speed equal distance over time. I will make 10 over 1 equals 10 kilometers per hour. The other one, Noor rides her bike 20 kilometers in 2 hours. How fast is she? We will make 20 over 2. 20 over 2 equals 10 kilometers per hour. Another problem, Omar rides his bike 15 kilometers in 3 hours. So we will make 15 over 3. 15 over 3 equal 5. So we will, here I will put 15 over 3. So the answer here is 5 kilometers per hour. Rana rides her bike 3 kilometers in 2 hours. So speed equal distance over time. Speed equals distance 30 over time, which is 2 hours. I will calculate it. It will be 1.5 kilometer per hour. The distance is 30 kilometer and the time is 2 hours. Here in this activity, we will put some books and we'll see that the car is moving for a long distance. Then we will increase number of cars, will increase the inclined. If, I put here 3 books. Now I will put 3 books. I will find that it will move for longer distance. At the first one, when I put 2 books only, it took 5 seconds and 3 centimeter. When I put 3 books, I increase number of books. It will move for 3 seconds and it will move 4 centimeter. When I increase number of books for 4 books, it will take 2 seconds and the distance traveled is 7 centimeter. From this, we conclude that as the speed of the moving object increase, kinetic energy increase. Both the speed and the kinetic energy increase as the angle of incline increase because I increased number of books. Here, our lesson is about changing speed. Changing speed, if you want an object to move faster, you must give more kinetic energy. While if you want an object to move more slower, you must reduce the kinetic energy. Of course, the modern car moves in a speed faster than the old car. When more force is applied to the object, its speed increase. When the speed of the moving object increase, its kinetic energy increase. If a driver wants a car to go faster, he give the car more fuel. He will press the gas pedal to send more gasoline to the car engine. It will give the car more fuel or more gasoline. This allows the engine to convert more chemical potential energy into the gas into kinetic energy in the engine. The product or the produced kinetic energy provide the force that turns the wheels faster, so the car speeds up. If the driver wants a car to slow down, he will decrease the amount of fuel. He takes his foot off the car gas pedal, so the amount of gasoline that sent to the engine decrease. The produced kinetic energy from the engine will decrease, so the car will slow down gradually until it will stop. Due to friction between the car tire and the road, the car will slow down and stop due to friction force between the wheel tire and the road. We conclude that we can make a car speed up or slow down. How to increase the speed of the car or make the car slow down? by increasing or decreasing the amount of fuel or the gas. Why? To increase or reduce or decrease the force applied to the vehicle to change its speed. Thank you, Junior, for